Adam, welcome to the show.
Hi, Sean. It's great to be here.
Yeah, thanks so much for being here. Let's start with some basics. Who are you? What do you do?
Yeah, so my name is Adam Ferrari. I lead engineering at Starburst, and I'm relatively new to the organization. Joined there in October, so pretty new in my journey, but excited to be part of it.
Awesome. How's the experience been so far?
It's a lot. We're doing a lot of really interesting stuff across a lot of big organizations, and so there's a lot to learn in pretty rapid order. A lot of interesting technical stuff going on, a lot of interesting business development going on. So it's like jumping onto a hurling freight train.
And then, what were you doing before you joined Starburst?
Yeah, I've been in the Boston area in tech for a couple of decades over, and I most recently I was leading engineering at a company called Salsify, which was a data platform for retail data. We were helping brands get their content to all the major retailers. I've been in sort of data stuff pretty much throughout my career. In the 2000s, I was the CTO of a company called Endeca that was well known for creating the first version of faceted search and sort of transforming how we search and also use search for analytical applications, which got me into the sort of the data analytics space. So yeah, that's a bit of it.
Awesome. So I talked to your CEO, Justin Borgman, about a year and a half ago. And,
Nice.
I encourage anybody listening to this that didn't listen to that episode to go check it out. We had a great conversation about some of the history of Trino, the open source project that Starburst was built on, how Starburst sort of transitioned into becoming a managed service available to like the enterprise. For anyone that missed that episode, can you maybe start off with helping them get their bearings and explain what Starburst is, what it's used for, what problem you're solving?
Yeah, absolutely. So Starburst, it's a great question. I think like we still like struggle to get like the identity well known out there, except for the people who really are in the data space. Starburst is fundamentally a data lake analytics platform. If you're doing anything around having a larger scale data lake or federating across your different data assets, you probably know about Starburst. The core technology is an open source package called Trino. It's pretty amazing. That gives us all of our superpowers. So on the one hand, we're a data lake analytics platform. And another way to think about us is as the enterprise provider of what we think is the best way to consume Trino for your big data needs.
So when you talk about it being essentially designed for data lake and analytics, when I think of data lake, I immediately think of like unstructured data. So is this only designed for unstructured data, or would this work also with something that might be more traditional, like RDBMS, database or something like that?
It's definitely oriented towards structured data. I think people think of it as unstructured. When you talk about a data lake, they think of it as unstructured only because in a data lake, it's common that like the data is in object storage, like an S3. But in reality, what's in most of that object storage is structured data. It's going to be in a format like a Parquet or one of the more modern formats like an Iceberg or a Delta Lake that is fundamentally structured. So even the data lake component of it is structured. And then the really interesting thing about Trino and Starburst is it's got a really great architecture for connectivity to other structured data sources. So you can be connecting to your, MySQL, your, Snowflake, any structured database, and then federating that together with your sort of object storage based structured data. So it really is about structured data and SQL, especially providing one unified way to SQL across all that. But spanning really traditional databases and object storage based models.
Mm-hmm. Okay. And then in terms of the concept of a data lake, it's been around since about 2010. But if you compare that to something like data warehouses or even a database, it's like a relatively newcomer in the world of data. So from your perspective, like what led to the growth and interest in data lakes?
Yeah, it's so interesting because I think it was the changing nature of data problems led us here. Data warehouses have been around for decades, right? Because people wanted to take all their corporate data and be able to drive fast queries on it. Transactional databases they were much more balanced for read write. They weren't suited for that task. But then what happened was sort of with the advent of the internet age was there were these new sources of sort of machine data and all the user logging that'll happen on these massive internet sites. There became a class of data that was like beyond the realistic, capacity and scalability of traditional data lakes. You needed something that was like way more scalable than that, internet scalable. And I think that's where the concept emerged from. We wanted a way to land stuff into sort of more of object storage, just fundamentally easy to scale, just keep dumping data in. It's very cheap to maintain. And then like you got, big data systems like Hadoop emerged to let you do something with that, crunch it. But they were fundamentally, in the original conception, MapReduce is totally a different model of accessing data than SQL, which is a lot more approachable and also has connectivity to all these kinds of tools, your dashboarding tools, BI tools, et cetera. And so that's where the data lake really, I think, came from, was the reality of this data we were amassing cheaply and scalably, but wanting it to kind of be usable in the way that our database, our data warehouse data was. And that's where technologies like Trino come from, was to bridge that and create an idea of a data lake being actually consumable, usable in a more data warehouse oriented fashion.
Mm-hmm. Yeah, you mentioned like MapReduce and Hadoop, and I feel like with that era of like big data was kind of like something that we applied because we basically didn't have like a better method for dealing with the scale issues at the time. And it was like a Band-Aid, or I don't know, like some chicken wire duct tape that we put on top of that was really complicated. And, luckily it kind of went away fairly quickly. But it was huge. Like people who were part of that era kind of, it's hard for them to probably conceptualize how big a thing that was during that period.
Yeah, absolutely. It is interesting. I mean, I think it was an answer at the time when there weren't other better answers. It fundamentally, I think about MapReduce, it came out of very specific problems. I mean, I was doing search stuff during those years, and it really emerged at Google, like for a couple of reasons. One was just basic indexing. You've got these heaps and heaps of unstructured documents that you're crawling off the web, and you need to index them. That's a MapReduce problem. And then like the idea of PageRank, of like, getting link weights and stuff. That's again, like, how do you kind of consolidate all the information? But, I remember using the original sort of versions of SQL on top of that to make sort of the more structured data more generally usable. And they were slow. They often, you'd get a query that would fail with a giant stack trace. It was kind of disappointing. And I remember the first time I experienced the predecessor of Trino, which was called Presto, and using it, and it was game changing. The experience was game changing. It felt like a database. It was like instantaneous. It worked, query after query. So it's absolutely something where it's like, yeah, there were those early days that got us doing something with this massive data, but it absolutely was just ripe for sort of a next level treatment, which is, I think, where we're at today.
Mm-hmm. And then you mentioned Presto there, which was the sort of precursor to Trino. What is the history of that? Where did those projects come from? And then when did Trino kind of spin off into its own thing?
Yeah. So Presto, which was the predecessor of Trino, was built at Facebook. This goes back more than a decade. And I'll just call out our CTO group here, Dane Sundstrom, David Phillips, and Martin Traverso. These guys and a group working with them at Facebook created Presto. And they did it out of necessity. Facebook they were on a gigantic, they were, I think, one of the biggest Hadoop and Hive clusters out there to try to analyze all their data, which was, massive, unprecedented scale, perfect example of why data lakes exist. It was obviously slow and cumbersome. They think they looked at commercial things, but nothing was at that scale and set out to develop this. So it was developed. I mean, these guys developed sort of this amazing thing for the most demanding data warehousing problem out there, brought it into the open source, and basically in the evolution of that, to take it more independent, they transitioned that project into Trino and continue to evolve it today. It's actually a really vibrant. It's one of these open source success stories. Really wonderful community, tons of people, tons of big organizations that utilize Trino, continue to contribute to it and evolve it. It's super vibrant, excellent governance on that community, which I think fosters it, staying healthy, staying fresh, and frankly, getting new capabilities at an incredibly rapid rate, which is wild to see.
Mm-hmm. Okay. And then back to the data lake. So, on the surface, I think like a data lake sounds great. You take, basically all your data, structured, semi-structured, unstructured data, throw it in the lake, make it usable through BI, ML, whatever, R&D. But the reality, I think, is probably a lot uglier than the like Instagram story version of running a data lake. So what are some of the challenges with actually like building, maintaining, and keeping a data lake usable?
Yeah, I mean, at the end of the day, it's a lot, it is more complicated and more sort of DIY or assembling a lot of different technologies to kind of source that data, format it, maintain it. It's a lot of more of a choose your own adventure architecture compared to like, a data warehouse is fairly opinionated. You're going to put some stuff around it. You're going to put ETL on the front and you're going to put, reporting and dashboarding on the surface of it. But it's very opinionated versus, a data lake. You've got to make all these decisions. And frankly, you go down that road. I've built around a data lake architecture in previous lives to great effect, and like it got great adoption. But it was one of those things where it does require more investment, more sort of documenting processes that you have to make up on your own because the opinionation isn't there. And it's actually something. I mean, when I look at the evolution of Starburst and what we're trying to do around Trino, is to bridge that divide and create more of a complete platform so that, today I think we're still in the era where data lakes are for people with the more demanding data problems, and therefore like the value's there. So the investment's there to put a reasonable sized team and to pull those technologies together that you need to make a real data lake and actually have the ongoing maintenance, documentation, data curation that make it successful. If you're not there, I mean, like, a data warehouse is an easy button in a lot of ways. You can, get it going and it's very opinionated, which, takes you down the road. So what we're trying to do, I mean, there are real benefits to a data lake architecture beyond scale. There's fundamental agility, flexibility, evolvability benefits. But today they come at this hard trade-off of like, oh, you're going to go on your DIY adventure to make a complicated thing. You'll get those benefits, but they come at a cost. I think a lot of those costs, they're things we can beat down by having more of an opinionated platform that helps walk you down that path, just end up with a slightly different architecture in terms of your data platform.
Mm-hmm. Yeah. I mean, how do you even think through sort of like data modeling when you're dealing with a data lake? When you're talking about a warehouse, there's, like you mentioned, there's like strong, basically opinions about how this should be done. There's tons and tons of references and books that you can follow, but with the data lake, there's a lot less sort of frames of reference, and it is more of this DIY approach. So how do you kind of think through those initial data modeling challenges and then have it something that's not something that kind of like, too rigid that shoots you in the foot later down the road when you need to like adapt it to something new? Yeah.
The beauty there is all of this prior work and thinking and literature on data warehouse modeling is completely applicable. In fact, I mean, in the limit, if you're crazy, we shouldn't do it this way. You could approach using a data lake exactly like a warehouse and model everything exactly the same way. You'd forego all these awesome benefits of agility that come from a lake, but you could kind of like all the same modeling concepts come into play. The idea with a lake is you don't have to it's not a big bang. You don't have to do all that up front. You can start out very flexible, very unstructured. The truth is like, these query engines are powerful. If you need to like, morph the data to look at it in interesting ways, you can start to build that into your query. And that's for more of your trailblazer users. And then like what a data lake lets you do is, let's face it, you're going to have your pillar data sources, your CRM, your ERP, your sales data, whatever it is in your organization. Those are going to be the first data sets that get super well curated in your lake. They may not even be native in your lake. They may be federated in by a warehouse because you're already there. And so that's great. That gives you a core to your data model. The lake and the way the lake operates is there's all these other data sources. You can acquire data. You can put more telemetry in whatever, online presence you have. There's a million ways you can get additional data in. The interesting question with a data warehouse is it's expensive. You do have to do the modeling sort of upfront and the ETL. It's expensive. So speculative data sources, you'll often make the decision like, okay, I've got to prioritize and do the ones that are more obvious from a business case. The data lake makes it super easy to create a world where you're like, hey, let's put that in. It's as easy as dropping a file and getting a little metadata on top of it. And then from there, you can start querying it. It may not be modeled perfectly. It may not be perfectly appropriate, but you can start to find out if there's signal in there. The data sets that are interesting, well, you put more effort into, and then you curate those as you go on. And, if they're really interesting, you go even further. You'll turn them into a data product with better documentation and like sample queries that make them more consumable. For some of them that don't turn out to be pay dirt, That's okay. You didn't pay a lot, and that's actually one of the fundamentally wonderful things about a data lake is it actually creates a culture. It's not even that it's data driven. It's sort of data seeking. You're asking the questions that are out of the scope that a traditional data warehouse organization will ask because they're too expensive to even pose in the architecture. It's one of these hidden things. I think so often we talk to customers that are looking at a TCO of their existing problems. They're like, oh, I've got my Snowflake bill. It's really expensive. Like, how do I beat that down by maybe taking some of this stuff and putting the workload into a data lake? It's awesome. I mean, it's a very, it's not, I'm not going to take away from the value. That's real money that you could invest in other stuff. But to me, the real transformation of organizations that embody a data lake is they do see and they collect more data. They're better at seeking out the data that answers interesting questions and actually using it to drive their business. It's a wild transformation to watch. I've been part of it. This is part of my sort of transformation. Part of why I'm at Starburst is I've got the religion of the true believer of having lived this, and it's amazing to watch. It actually is. It has wonderful effects, and you see more users. It's viral. You see more users in your organization seeking out data, trying to like learn and become more literate on analysis. It's actually really an amazing thing to watch from a transformational perspective.
Yeah. Do you think, part of the value of the data lake is that there's sort of like a separation between the actual data that you're storing in object storage with essentially the metadata that you're going to use for sort of making it like queryable. So there's like a natural abstraction that's happening between the like actual like raw data and then sort of attaching this metadata. So does that give you more flexibility in terms of doing something one way and then kind of like throwing it away down the road when it's not working?
Yeah, that's part of it. I'm not going to lie. The cost model of using object storage for stuff that is speculative is pretty amazing, especially with, this is, I think, part of what's driven data lakes is the evolution of more and more efficient and also capable file formats, and now on disk table formats that like actually make, you're getting the cost of storing your data in S3, which is dirt cheap, right? That's compared to like storing it in a like first class data warehouse. And yet you're getting these formats, with Parquet, we got sort of a columnar representation that was incredibly fast to scan. So suddenly like the performance trade-off now with the Hooties, Delta Lakes, and I think Iceberg is probably, in our view, is really the front runner in terms of openness and capability. You're starting to get like a really nice set of semantics, ability to do updates, ability to take snapshots. It's really incredible. So you're kind of like, I think one of the unlocks in the space has been smarter and smarter, formats that still let you achieve this decoupling of your compute and storage. So you're paying the sort of the S3 rate for your data, which is amazing.
Mm-hmm. Yeah, absolutely. So I want to walk through like an example. So let's say I have, a bunch of data being stored in object storage, it's like S3 or something like that. And then I want to go through the process of actually creating a data lake. What am I using to sort of keep the data, organized and queryable? Like, what's my first steps to kind of like turning that into something that I can actually use for analytics to start to drive insights for?
Yeah, if you've already got an S3, well, then you've got an amazing leg up. There in many cases there might be a prior step there where, in the simplest cases, like you've got something coming off of a SaaS application, it might be as easy as getting an export, but it's going to come in some format that's usable but not ideal. It's going to come in a CSV or something like that. More interesting sources, you might have, data you want to replicate out of a database, and, you need to do some ETL or change data capture, that kind of thing to get it in. If you've got streaming data, you've got like stuff going over Kafka, and, you'll need to figure out a way. And this is stuff we're working on building into the platform, is ways to kind of connect Kafka streams and actually land them into the lake. So there's in many cases, prior to what you pose, there's work to do to even get something into S3. From there, your next juncture is making the data useful in a query engine, and that's getting metadata on it. It's like understanding like what's the format, what's the actual schema represented in that, it's going to be how's it actually laid out on disk. It's like all that metadata that makes it consumable by a query engine, and getting that available in a metastore in some kind of a catalog. Could be Glue, could be Hive Metastore. You've got to actually get that available so that a query engine could come up and say like, okay, I can look at the definition of that table and now I know what I'm going to find on the disk when I go there. And again, this is stuff where bridging there, like having built-in catalog capabilities and having schema discovery type capabilities. This is stuff we're building into the platform to ease these steps. These are DIY steps that we're trying to like sand off the work of and have them be more built in. From there, you're golden, because now you can write a SQL query. And there's a ton that you can do there. You can, use SQL to like if you're just exploring the data for the first time, maybe you're done at that point and you're actually just posing some queries. It's just you as an analyst and you're trying to figure out whether there's a there there. Maybe you do figure out there's a there there and you're like, oh, I've got to make these queries fast. They've got to show up in dashboards. They've got to be made available to interactive, users. And from there, you might want to like transform the structure, the format. Maybe you want to turn it into an iceberg. This is the kind of stuff where, there's a lot of capability in SQL itself, like in an engine like Trino, to do that work right in the engine. Once you've got the data, once you can get that, that connection into the data from the engine's amazingly capable at doing like ETL workload, transformation workload. That's kind of stuff that you can do right in the environment. So in a way, the game with the lake is about getting a toehold into your operational, query engine environment, and then from there you're really golden. You can pretty much do anything very efficiently and at scale.
Yeah, I remember when I talked to Justin last year, one of the things he mentioned that he was, I think, like somewhat surprised that people ended up using Trino for and the Starburst Enterprise version was to actually perform these transformations from essentially like data format to data format.
Yeah. It's in a way, I think it is actually a sort of a delightful surprise. In another way, it's kind of, if you look at the evolution of ETL, which started out like way more of these specialized platforms, the Informaticas of the world, and it really evolved into like ELT, like get your data in and then use SQL. Like, why do you need more languages and representations to actually work with data? Once you've got a toehold on it, use the environment. And so, surprise, surprise, once the SQL became native to the data lake, this concept sort of transported, because it was in sort of in everybody's mental space of that's how you work with data. And so, yeah, I think it's played out in a way that's great for the user experience and also kind of makes smart reuse of all the technology investments that are being made.
Yeah, and it's less expensive than moving your data around.
Exactly. Yeah.
Mm-hmm. So once, we have essentially we have things flowing into object storage where we figured out how to essentially, define the metadata so that we have some way of essentially making it queryable. How do you actually like keep up with the performance demands? Like as this thing scales, how do we actually make it performant?
Yeah, that is one of the key investments, I think, in terms of lake maintenance. If you're successful, you're going to drive consumption of the data. If you drive consumption of the data, you're going to hit demands on performance. Also, you're going to hit demands. What I've experienced is you hit demands on consumability. Just like people understanding like, what is this? And like, what are the definitions in there? It's non-obvious stuff. Like you might be looking at like your Salesforce data and you've got an ARR column and you're like, oh, is that like, what if that's a multi-year term and what's the, you start to get into these little, they're small but meaningful definitions in terms of getting the right answer out of a query you make. There's that performance. There's a whole set of activities that you want to do. One is, probably the most basic one is getting it into a higher performance, file format. You might land your data in whatever, getting it into Parquet or ideally one of the modern table formats like Iceberg that builds on that. It's like that'll get you a certain amount of speed. Then there's like the traditional like database design. Do you have appropriate partitioning, ordering, those considerations based on the kinds of query workload that you anticipate. The kinds of stuff that enable things like a smart query engine like Trino is really powerful in terms of not just its ability to process the data in parallel, but also push down predicates. So the more leverage you can get in the underlying store and how it's laid out, to handle that in relation to your query workload, the better, kinds of query latencies you're going to see for the common queries that you're doing. And then there's other stuff. I mean, again, this is like, because it's a never ending, there's those base kind of design considerations. We as Starburst, just in terms of making this easier and having more, tricks up your sleeve in terms of delivering performance, we've got capabilities we're building into the Starburst platform around Trino. Like, for example, one of the things that you can do to make object storage better is like smart caching. It's like if you want to have faster access and you're caching that. So like we've got a caching and indexing layer called warp speed that's built into the platform. So, caching for access to be faster, indexing so that like there's more interesting predicate pushdown that can just retrieve the relevant data when that kind of query comes through. Like you've got a where clause that's very selective. You're just looking at like the last day of data out of this mountain that's got years of data. That's great. That should be leveraged to turn that query around really, really fast. But you've got to have it laid out and indexed. And so having something like warp speed is a way that we put in the box more smarts and easy buttons so that you can get that kind of performance out of workload with those characteristics.
Mm-hmm. Yeah. And I think also for some of these types of things, the performance demands are different than, it's not like you're necessarily you need like real time, performance or, less than 10 millisecond, query operations for some of these things. If you're basically unlocking access to data that you never had access to before, then it could be okay that the performance, even takes multiple minutes essentially to do the computation if it gives you insights that you never had before as a business.
Yeah, certainly. I mean, it is. I will say though that it's maybe not for the most demanding real time, but it's amazing. The Trino engine it's blisteringly fast, and so just as I used it for years before joining Starburst, and as an interactive user, just trying to get at my data, and it's really amazingly conducive to data exploration, getting quick answers to questions. I remember a lot of times being in meetings and a question coming up and just being able to quickly type some SQL and answer a business question in real time. So it's great, especially I think for that kind of human data access. It's amazingly fast. And again, it depends on how smart you've set up your data, and it depends on all those variables. But in terms of what you can deliver on it, it is actually a pretty amazing technology.
Mm-hmm. And you mentioned Iceberg tables a couple times, and I feel like it's something that is becoming more and more popular, and it feels like that's kind of like the weight of the industry is kind of leaning towards Iceberg tables and moving away from other types of formats. What is it that Iceberg tables are doing that has made them popular, and what is it, how is it different than essentially some of the formats that had been used in the past?
It's really beautiful in that it layers on all the work of formats of it layers on things like Parquet. So if you were to actually, if you look at an Iceberg, it's a whole directory of files underneath there in the Iceberg table, and there are different segments and updates and parts of that table structure. If you then crack into one of the underlying leaf files, it's going to be a Parquet or similar, and what it's fundamentally done is on top of the actual raw data, it's maintaining metadata. It's got a manifest that's tracking versions and updates, and it's laid out in such a way that you can atomically land updates. It's laid out in a way such that if you haven't pruned out a version, you can sort of time travel back into a version, because it's just about what files constitute underlying files in the directory constitute that version. You can then, get that snapshot version, which is actually pretty amazing. Honestly, one of the perennial problems in analytics is sort of dueling numbers. It's you get different numbers. And so being able to say I want to see the data as of this moment at a specific time in the past, it's really, really cool property to have out of the box, out of the table format. And just by intelligently managing the set of underlying, parts of the file, having a manifest on top of them that keeps track, does all the bookkeeping appropriately, such that you can keep all those versions straight in addition to putting in new versions. So it's what it does, what it creates, honestly. And this is, I feel the journey of, this goes back to the earlier, discussion we had about like the evolution from Hadoop. I feel like the data lake space, it's been on a journey. It's gotten more and more database like along the way. It starts out like with Hadoop looking nothing like a database. It's a bunch of giant data sitting in files with like general purpose computation and MapReduce on top of it. And like it ends up with SQL. And now like with Iceberg, connecting Iceberg's got really great integration into Trino. And like, you start to be able to do all these inserts and updates, and, it becomes much more just like a SQL database, but you're still operating in the underlying architecture where that compute layer and the storage layer are independent, and you get all the great properties and flexibility that comes from that. So it's wild. Like I'll be honest, in my past, lake that I was most recently in the organization I was where we were using a lake, we weren't on Iceberg. I wish I had known about it, because it cleans up so many of these basic problems and adds so much richness without cost. It's almost like magic. It's this layer of intelligence that isn't really adding that much cost to anything.
Yeah. I mean, in terms of like you mentioned that with the lake, essentially, we went from, MapReduce and now essentially everything's sort of queryable through SQL. And I just think it's similar to like the, if you look at something like MongoDB and the document store, like originally they were called NoSQL stores because they actually didn't support SQL, but then they added SQL because they found out, okay, well, people actually want SQL. So it feels like everything that kind of starts out as something different eventually converges to being like SQL as sort of the way to the like interface for actually interacting with it. So do you think that the lake and the warehouse is kind of like converging, like essentially these like concepts are coming together in some fashion?
I do think that, I mean, it'll be interesting to see, a warehouse is a specific, highly integrated, like integrated storage and compute. And there's stuff you can do. I'm not going to lie. The value of that stuff and what portion of your workload really benefits from that, maybe that like last bits of performance. I think that remains to be seen. I really do believe like the project that if you look at the overall set of things we're doing to add more opinionation and completeness to the Lake platform, I think for many use cases, it does start to cut into what you would have wanted to do in a warehouse. I mean, data warehouses, it's one of these like, long-term, highly, incumbent and entrenched technologies. But I think for many organizations, especially for, if you've got anything like a greenfield or a re-platform, today you are making a trade-off choice to go lake versus warehouse. I think depending on the space of your requirements, that's going to become less and less true. And you're going to see many, many cases where, a normal organization that today it would be too exotic for them to go with a data lake architecture. They're like, I'm gonna take the out of the box, it's structured, the warehouse. I think you're going to see more and more cases like that, and it'll start with the more interesting, like organizations that have more complexity to the data problem. But I think it'll reach down into organizations with more standard data. And so I totally agree. I think there is a bit of a sorting out there. And again, it goes back to for me, the benefits of the lake are flexibility. It really opens up what you can do and how quickly you can land new data in there. And, it's fundamental. You look at what many organizations do, their answer to the lake is instead to do an export into a spreadsheet. And then they take their data that they're trying to their new data that they're trying to understand and put it in a spreadsheet. It's scale limited. You end up with dueling spreadsheets that have different representations of different data. It's just so messy. There's such a better way to do that version of data experimentation that people intrinsically, they want to do, which is to create a lake, make it super easy to experiment with new data, make it easy to then promote that data that's the winners into the main lake and make it available to more and more users. I do think that there's a very natural evolution there. And it is funny, SQL, you mentioned SQL. SQL is one of these technologies that's clearly like there's a bit of manifest destiny to it. There's something about its just learnability, its expressiveness, simplicity. I went through those NoSQL years, and was really thought it had a lot of legs, but SQL is the terminator of query languages, it seems.
Yeah, it's like every time you think SQL's dead, it comes back with stronger than ever, essentially.
Yeah, exactly.
Yeah. Well, so we talked about how the Hadoop era MapReduce was kind of like we had that essentially available to us because we didn't know a better way of solving this problem. And the warehouse in a lot of ways it's not like a net new technology. We've transformed it to the cloud, but
Yeah.
it's not that different than what existed sort of in the on-prem world and so forth. So do you think maybe the future is essentially, or I guess like the point I'm trying to make is with the warehouse, like we had to use that technology because we didn't know how to do this with like the lake architecture. And now we're to a point where we can actually apply the lake architecture, but also make it performant. So is that essentially the future that we're sort of moving towards? Because companies are going to have more and more complex forms of data. And there's a lot of work to essentially take data from one place, export it in one format, transform it into something so that we can stuff it in an expensive warehouse versus just putting that raw data wholesale in the lake and then using the other technologies that we have available to us to essentially make it suddenly queryable and actually derive insights from.
I absolutely agree that that's kind of the direction. The thing I'll say, and maybe one of the more interesting aspects about Trino and what it's capable of, is that like, I think what you're describing is going to happen, but if that was something that had to be like a forklift transformation, if you had to suddenly be like, I'm going to go lake now, I'm going to actually, that means I have to, offload everything from my warehouse. I think that would be a huge barrier to entry. But like with federation capabilities, you can leave, like if you've got a giant cloud data warehouse, you can leave it all in place. Trino is incredibly capable at querying that, pushing, for instance, predicates down so that you only retrieve, what's necessary, taking those results back and parallelizing, combining them with stuff from the lake. It gives you this idea of sort of data federation, or a data mesh is sometimes used to describe this concept, a practical evolutionary route to the lake. The lake is where all the benefits, I think, really are in terms of flexibility, agility, and cost. But like, you can't say like you got to go there in a big bang. But if I could offer you an incremental path that like, and by the way, some of those, if you've got relatively slow changing, well managed, stuff in databases or warehouses, you may never, or it may take you a long time before you ever bother to move that, because who cares? And it works perfectly fine. So I honestly think that like, a lot of what I think about in the space has a gravity towards the data lake. But like being practical about the reality of data platforms is they're very heterogeneous, and there's a lot of existing investment that's been sunk into them. I think that like a platform that's going to drive the journey to the lake has to be, something like we're looking at where it offers a federation capability that gives you an incremental journey along the way and benefit from the investments you've already made. Just being practical.
Mm-hmm. In terms of Trino, how does what's going on, I guess, like under the hood to actually make it scalable and performant working with these kind of technologies?
Yeah. I won't go. We've got like in Starburst, including the CTO group who created the technology. We've got like many of the maintainers are here. Not all, there's like actually maintainers and contributors in many other big companies and stuff, but we definitely have an amazing crew here. So I won't claim to be the expert after my first, 4 months in the organization by any stretch of the imagination. But like some of the things that are very clear about the technology are it's very, very good at parallelizing the workload. It's really good at chopping the work into granular tasks, scheduling them across the cluster in a really efficient way. And you can operate this at massive cluster scale. You can throw tens or hundreds of nodes at the giant data problem. Came out of Facebook. So it really was built for cutting the work. This is why it's a strangely counterintuitive thing that I had to come to understand about the data lake. You're like, oh, how could it possibly be efficient? You're storing this data in these inefficient object storage, but it cuts it up. If you chop up the work, the access and the processing into granular enough bits, you can do amazing things in terms of turning around queries very quickly. The other thing is the architecture. They really developed a beautiful architecture for extensibility. They have these extension points called the service provider interfaces, SPIs, and that's where you plug in things like data sources, underlying databases, object storage systems, or even like, you can have NoSQL, like Elasticsearch will plug into it, or Mongo will plug into it. Like you've got these connectors to systems. And what they do that is, I've already kind of alluded to it, is Well, they're doing all the semantics matching. Like you have to actually come up with one semantics which involves sort of how do you handle the types and the semantics of the underlying databases. It does that, but it's also smart. It's like it's got it in that SPI. It has knowledge of what it can push down in terms of predicate filters or aggregations that can be handled by the underlying source, so that you're pulling back more distilled data. So it's like between parallelizing and processing in place as much as humanly possible, you really get amazing performance and scale out of the thing.
Mm-hmm. And so, like normally in like a traditional database, you kind of have like these two systems. You have the sort of the piece that's in charge of the query engine, and then you have the actual like storage. And then with Trino, essentially, it's like a database that only does the query engine piece. Yeah. And then the storage is kind of like separate and handled by these different, separate technologies. Yeah. So how does something like a join across these different pieces, basically that could be like different separate data storage, like work across one single query interface or query engine?
Yeah, and it's a great question. It absolutely does that. So first of all, it's got a smart cost-based query planner. So, if there's work that can be pushed down below the join, especially filtering, right? If I can pull back less, there's less stuff to join. That's great. So it's got a smart query planner that'll do that kind of optimization. But then, right, it's able to pull back the data into the worker nodes in the cluster. It runs on a cluster architecture. And it'll actually pull that data back, and it's pulling data from other sources. So you might have like in one query, you're pulling data from like, multiple different kinds of sources, chopping those into small bites. There's like, obviously there's data shuffling, and or there, it'll do smart things around join selection. If you're joining, a very small table against a big table, you might broadcast that. You do a broadcast join, or like it's going to do smart sort of algorithm selection for the join. But at the end of the day, it's going to shuffle the data such that you're doing joins in small nibbles with the stuff that matches up in the way that it needs to. So it's just very clever. This is traditional. Like it's a combination of really nice, architectural design with some of the core. These are long-standing distributed database concepts of how you do a parallel join, combined with the fact that you've abstracted those underlying sources. From the engine's perspective, once it's doing join, it's almost like it doesn't matter where the data is coming from. It's abstracted away, which is beautiful.
Mm-hmm. And then what about something like data governance or controlling access to these different data points? How do you essentially do that consistently across, essentially, it could be like a bunch of different types of technologies that are underneath?
Yeah, I mean, and you can have like access control at different levels. Like even like hitting like a lake, like if I'm hooking up to data in, say, my S3, I'm gonna create an IAM role that'll let the system get into that, with whatever minimal privileges I want to provide. So there's that like underlying system access that you can use to kind of lock down what's available for access. But then on top of that, it is really very much like a database with a full sort of access management system where you can kind of go in. It's got roles that you can define in a whole permission system. So like in terms of just defining this, honestly, this is again in the space of opinionation, providing an out of the box access control system that's sort of opinionated and database like. It's one of these things that like in my past building this is something you would have DIY'd. You might have used an open source access management thing like Ranger. And so again, you're in the business of assembling the platform. With a Starburst, we're trying to like put more of that right out of the box so that you don't have to invent it. It's something that's built in.
Mm-hmm. I see. And then you mentioned warp speed earlier, which is the caching layer.
Yeah.
How does something like invalidating the cache work? This is one of the classically hard caching problems.
Yeah, and this is one of these ones where, the simple answer is right. The warp speed technology sort of lives right in the Trino cluster. It's kind of built into the Trino processing. It's inserting itself like between the actual query evaluation and the data access, and it's like looking at the traffic, caching stuff, indexing stuff based on the workload, and based on analyzing the workload, it's there's simple stuff, just like, what's been recently used. But like, it is something like, in terms of continuing to evolve that technology, there is smarter and smarter workload analysis that you can do, looking back further, looking at the trends, what has value, so that you can have a smarter and smarter cache replacement policy. So today it's simple but effective, but I think, this is an area that we're continuing to invest in and make it smarter, so that you make best use of your limited storage on the cluster.
Mm-hmm. What are some of the other types of investments that you're making at Starburst?
Yeah, there's some really, really cool stuff. We've been on a journey. This is one of the more game-changing things, in terms of building forward in terms of what Trino can do. Trino introduced an abstraction layer where you can do persistence of intermediate results in a query. So this is a sort of a new mode of execution for the Trino cluster called fault-tolerant execution. Trino is fundamentally an in-memory engine, but like, well, what happens if you lose a node mid-query? Historically, the answer would have been you had to start over, which is a bummer. But if you hang on to intermediate results, buffer them, you can start off mid-flight. So we're working on, better efficiency for, analyzing queries that way, making it more and more competitive with the purely in-memory execution mode, offering more like, resiliency and better ability to handle like longer running, like ETL-oriented workload that might run for a long time. We talked about Icehouse a little bit. That's one where we're doubling down. So I would expect us to, continue to track that and expose the capabilities of Iceberg files, but also, build in more out of the box ways to sort of populate your data in the lake. I mentioned the first one of those was sort of a streaming ingest that we've gotten sort of preview right now to pull data off Kafka and land it in Iceberg files. I'd expect us to keep doing things in that neighborhood. So this is, I mentioned at the very top, it's like there's a lot going on. It's like jumping into a moving freight train. There's a lot of areas of investment, and we're trying to focus them. I think the vision, if it's come through along the way, is really strive for completeness, and make that data lake concept accessible to more Main Street customers who may not have the wherewithal to construct and imagine their own data platform. So I've omitted about 1,000 things that we're doing, but those are some of the ones that kind of like stick out to me because they're part of that journey.
Yeah, I mean, the data space isn't getting smaller. It's it's getting bigger and more complicated. So you mentioned streaming there and Kafka. What kind of like new challenges does integrating with like a streaming service add to like the complexity of essentially, managing a lake?
Well, I think actually it's not really from the lake maintenance, but the problem in and of itself is challenging. Just to keep up, you've got to, actually be like catching the, streams can come in very high volume varieties, and so you've got to like keep up. So it was one of these features that on the surface sounds simple, but ended up being a pretty substantial investment in the actual extra process architecture to consume the stream and efficiently turn it into Iceberg. Also, if you really are, flooding data into Iceberg, it's like you got to be smart about like how you're applying those updates. Keep the Iceberg, consumable and efficient to process. So yeah, it definitely it brought new architecture challenges, but at the end of the day, I think it's so valuable in terms of an example of having more ingest capabilities, because that is streaming data is one of the motivating use cases for the lake. It's something where you're like, okay, it's just going to be a pain and so expensive to keep up with that in a warehouse. So of course we landed in object storage, and how much nicer to be able to then query it readily than to have the separate ETL step and all the like kind of hard decisions about like, what do I make queryable and how do I manage that with reasonable cost. You can have it be part of the platform with good cost and all queryable depending on what you need to do.
Mm-hmm. What do you think the like big problems or challenges in the data lake space are that are yet to be solved?
That's a great question. I do think that there's plenty of meaty problems. I mean, I mentioned, really being able to execute longer running queries without it, being a big performance sacrifice. I honestly think like I don't know if it's such a deep technical challenge so much as it is like it's a product. It's like a product challenge is, fitting the right shape of sort of platform completeness to unlock the lake for those more common customers, the customers who aren't going to be doing the most complex stuff. I think there's a never-ending set of performance challenges. There's absolutely keeping up with the space of the lake formats, like Iceberg. So there's a lot of sort of meaty things in terms of grand technical challenges. I don't know. There's probably big concept ones out there that I'm missing, but there's certainly plenty to keep us busy in the meantime.
Yeah, it feels like one of the kind of like most relevant challenges at the moment is putting the right technology together to make the lake actually usable.
Yes.
Without basically lower the barrier to entry.
Yes. Yeah, and I think like from a product perspective, as a vendor trying to build a product, it's interesting balancing. Part of the brilliance of the lake is that it's been built in a very open environment, and there is composability, and there's room for lots of different technologies that add value, and we don't want to lose that composability and customizability. Yet at the same time, kind of like I'd love it to be the case that to get going, there's a box you can open and it's got the main pieces, or at least basic versions of them, and you can very rapidly start building on a data lake and getting going. So that's a bit of a balancing act. At the end of the day, I mean, I do think in this space, it is really there's a whole bunch of different companies and technologies that are partnering together and solving the big problems. And you never want to lose that, connectivity. I think even as I was joining, one of the things I observed, and I was really proud to be joining the company, was I started looking around at all the relevant tools, all the BI tools, your ThoughtSpots and Tableaus and stuff, and all the tools for creating, managing your data like a DBT. Like just looking across in the ETL products, and everywhere I went, I saw like Starburst was at the top of the list of integrations, up there with the big guys, and I was like, all right, this is great. Like we've got a really smart partner organization that's out there working with the other technologies, because I think it's so essential. It's not going to be one company show. But yet, like, I do hope we can build something that stands on its own and really lets you get going without a lot of complexity.
Mm-hmm. Absolutely. I mean, I think having those like partnerships and those like sort of simple integrations is what helps lower the barrier to entry, because if you have to go and do essentially like a bunch of DIY work to, pull this thing together and plug this thing over here and so forth, like it just adds more and more complexity and also probably more risk to making a mistake.
Yeah, 100%.
Well, Adam, I want to thank you so much for being here. That was a really fun conversation. I think we covered a lot.
Yeah, it's really been great. Great questions, and it was fun to get to talk Starburst and Trino for a bit.
Cheers. Bye.
Thank you.